All right, so we're going to go over a few techniques in the carbon NMR, and this will help you determine the structure of the compounds. Okay, the first one is called proton-decoupled or broad-band-decoupled carbon NMR. Well, that's a lot of names. That's a long name. Okay, this actually we just call it a regular carbon NMR. Anything that you have seen before, or the carbon NMR spectra, uh, it's just that same thing, regular carbon NMR. Okay, and if you remember, the carbon NMR gives you two important informations. If you remember, what are they? Number of signals and the chemical shift. Okay, all right, let's do this. So before I told you about this technique. Okay, this compound right here, how many carbon NMR signal do you expect? Well, let's count. Right, we're gonna go 1, 2, 3, 4, 5, and then 6, 7, and 8. Yeah, there's a little symmetry there. All right, so we expect 8 signals. Let's take a look at the carbon NMR of this compound before doing the first technique, the regular carbon NMR we talked about. All right, a regular carbon NMR, like a raw carbon NMR of this compound, look like this. They're just really complicated. It's much more than 8 signals. Okay, way over 8 signals. And what's going on? Well, what's really going on here? Carbon NMR can couple or can communicate with a proton. Right? We'll learn about proton NMR later. So proton and carbon 13 are NMR active. And these are just they send a signal and they just communicate with each other and just show up like just a lot of signal, right? And excuse me, this carbon signal happen because it's coupled with protons. It have some interaction with the protons, so we call proton couple or just raw carbon NMR. Since the proton interfere with all the signal, so we this technique we call regular carbon NMR, or we call proton decouple, remove proton from the spectrum, the interaction with the proton. Now we got this proton decoupled or broadband decoupled carbon NMR or regular carbon NMR. So basically, these are carbon NMR that remove the interaction of that carbon with the hydrogen on it. That's why you see 1, 2, 3, 4, 5, 6, 7, 8, 8 signal, just like we predict earlier. Okay. Anyway, so a regular carbon NMR, just ignore the interaction between carbon and hydrogen. That's why you see a nice carbon like this, the carbon NMR signal like this. All right. Now let's take a look. So a proton decouple is necessary for determination of larger molecules. So if you let carbon have interaction with a hydrogen, look at that. There's just a lot of signals there. All right. When you do a proton decouple, remove the interaction with proton. Look just nice. Okay. All right. I want you to pause the video and then count how many signal do you expect, and then I'll have you count down here. All right. All right. Let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, don't forget that. That's right there. Next to oxygen. Most people didn't see that. Don't see that. Okay. So, hold on. All right. Let's count down here. How many? 1, 2, 3. So there are 2 signal right there. Right. 2, 3, 4, 5, 6, 7, 8, 9. Do you count this? No. There's a solvent. That's a solvent. Okay. So we have 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There we go. 20 and 20. All right. So, all right, that's the first carbon NMR technique is a proton decouple. Remove the interaction between carbon and hydrogen. So we see have a nice, clean carbon NMR. Okay. The next one though, of resonance decoupled carbon NMR, usually used for the smaller molecules. Okay, so it tells you, this technique tells you the number of hydrogen on each carbon. All right, let's take a look at this on the next video.